review, because everyone loves word problems, the sum of two numbers is 32. Let x represent one number, write an expression for the second number in terms of x. So if the first number is x, what would be the second number? Instead of using another variable, it says in terms of x. Anyone guesses? Yeah?
32 minus x?
Would be 32 minus x. Because the sum of the two, right? So if the second number was y, you could say x plus y equals 32, right? If you did let the second number be y, then x plus y equals 32, which gives us y equals 32 minus x. Same idea. So in terms of x, 32 minus x. Write an expression to represent the sum of the squares of two consecutive even numbers. Boom. That's a lot of math terms. So, first of all, summing. Do you know what summing is? Let's get that down. Adding. Same thing as adding, right? Squares. What are squares? Power of 2. Okay, well, other than like the shape of square, yeah. Which the shape of square, side length, side times side is side squared. So we're talking about summing squares. We're summing like 3 squared and 4 squared. Next thing it says 2 consecutive. What does consecutive mean? Like 1 and 2, one after another. Now they're saying consecutive even. Give me an example of consecutive even numbers. 2 consecutive even numbers. 2, 4, what else? 6, 8, so on, right? They're consecutive, one after another. Notice the distance between those two numbers. What is it always going to be? 2. Okay, so if the smaller number is x, what's the larger number? Would be x plus 2. So how would I write the sum of those squares? How do I write x squared? Well, that's easy. X squared, right? Plus, how do I square x plus 2? Just use brackets. So that would be the sum of the squares of 2 consecutive even numbers. Okay? That's going to show up. Many problems involving trying to find the optimal solution, which is usually the maximum, like max profit, minimum cost. And so that's why we need the vertex, because the vertex will give us the max or the min value, which is why we're going to complete the square. Okay? So here's one example. It's already been given to you. We're just going to walk through. I'm going to grab a highlighter and just walk through it with you, and then we're going to go through some of our own. Okay? It says two numbers have a difference of 10. Their product is a minimum. Their product is a minimum. What are the numbers? So whatever your equation needs to be whatever you're trying to maximize or minimize. Okay? So in this question, I'm trying to minimize product. Now, first of all, do you remember what a product is? Two numbers multiplied together. Okay? A product is multiplication. So we want to, whatever you're trying to minimize or maximize, that's our formula. So that's why we have product equals x plus y. Okay? So you have to define your two variables. First number is x, second number is y. Now we've kind of been through this before. What's wrong with this formula? 3 variables. How many variables do we want? 2. We want 2. You want 1 to solve, 2 for max min problems. Okay, so in the second half of this unit, we will be solving problems, which you only need 1 variable to solve. If you want a max or min value, you need 2 variables to get an equation so we can get the vertex. Okay, so that's where they're going to give you some other information. In this case, they say two numbers have a difference of 10. There's a few ways you can write this. We start with x minus y equals 10. So we're going to isolate one of the variables so we can replace it in the formula, just like we did with the area stuff. So you can write this instead as y equals x minus 10. Okay, and so when we We're going to replace one of the variables. In this case, y was replaced with y minus 10, and we get our equation for product. Product equals x squared minus 10 squared. Now, earlier in this unit, we just grabbed our graphing calculator, graphed it, and found the vertex. Now, we're going to try and find the vertex by last 2 days, or the last 2 school days, completing the square. Okay, and so that's what we're going to do. We're going to complete the square to find the vertex, and from there we can answer our question. So in this case, the minimum product would be negative 25, and then one of your numbers is 5, because you're comparing product with x, one of the numbers. How do I get y? Then you're going to go back to this equation that you made before. Okay, so once you know your x value, and this is your product, you could sub in x, that's 5, and you get negative 5 for your y. So your two numbers are 5 and negative 5. Okay, so this is kind of like the thought process. You can read through it in more detail if you want on your own. Let's try some together. Next page. Two numbers have a sum of 24. Their product is a maximum. So because we're trying to maximize product, that's the formula we want to make. So how do I make that? Product is equal to product of any two numbers, x and y, x times y, right? Product equals x times y. So whatever you're trying to maximize or minimize, that's your equation you want to make. Next step is to get rid of one of the variables. We only want 2 variables, we have 3. So what am I going to use to get rid of the other variable? There's another equation here. What's the other equation? Yeah. Two numbers have a sum of 24. X plus y equals 24. Who do you want to get rid of, y or x? Y? Sure, let's get rid of y. So let's isolate y. Y equals what? 24 minus x. Subtract x to the other side. That's all we did. Move it over. So we do that so we can replace y. We're going to replace y with y was equal to 24 minus x, so let's replace that. Here, do you want me to zoom in? Is that better? A little bit? Okay, so replacing y with 24 minus x. Now what do? Expand the rainbow. I can't hear you. All I hear is Miss Burnham. 24 times x, so 24x minus x squared. Or, if I want to complete the square, what order should it be in? Sorry, EJ. Negative x squared plus 24x. We want to put the x squared first if we're going to complete the square. All right. How do I complete the square? What would be my first step? Factor out what? The negative, the a value, out of anything with an x. And so we want to pull the negative 1 out. So this becomes x squared and negative 24x, right? If we factor negative 1 out, now let's go straight to completing the square. This is actually one you could probably reason through in your head really easily. Okay, negative 24 divided by 2. 12. 12 squared? 144. If I add 144, subtract 144. In order to bring the negative out, what do I have to multiply by? The negative 1 outside. So this becomes x squared, minus minus 24x plus 144. And what's on the outside? Plus 144. Or in factored form, what does that factor to? X minus 12. Remember, we take the middle term and divide it by 2? X minus 12 times x minus 12 plus 144. So what's my vertex in this case? Negative or positive 12? Positive 12 and 144. So this represented the x. What did the 144? What are we comparing? Is that the y value or is that something else? That's the product. Your y value is p here, right? That's going to be your maximum. Maximum product in this case. The max product. So if the first number is 12, what's the other number? 12, because y is equal to 24 minus x. So 24 minus 12 is 12. So our two numbers are, which makes sense if you know a product tree, are 12 and 12. All the ways we can add to 24, the largest product we can make are if they're both 12. It's a square. Squares are going to be the largest. So no real surprise there. But that at least took us through the process of how to get it algebraically. Okay. Okay, you ready for a revenue problem? So this was a number problem. We're going to do more number problems like that tomorrow. You'll have a bunch in your homework. So this is an area, or sorry, not area, a revenue, the next two. Once you get revenue problems, they're really simple. The same process every time. However, just take some practice. But it's the same process every time. Can't read this. Karina makes and sells holiday wreaths. How fun. I'm going to zoom out for a second. Last year, she sold 45 wreaths at $18 per wreath. So last year, well, how much revenue? What is revenue, first of all? Money coming in. Okay, so it's a little bit different than profit, because with profit, it's your revenue minus your cost. So revenue is money that's coming in, whatever money's coming in. So it's not always the same thing as profit. Okay, so last year, when she sold 45 wreaths at $18 a piece, what was her revenue last year? How would I get that? 45, the number of wreaths, times $18. So how much was that? Multiply them, what was it? $810. So she made $810 last year. Or I shouldn't say made, she brought in. That's how much money she brought in from her wreaths. Wonderful. Lucky girl. That's pretty good for some wreaths. They must be really nice wreaths. Okay, so she knows from experience that for every $2 price decrease, it will result in the sale of 15 additional wreaths. She did some market research. So for example, if she made her price, she decreased it by $2. So she made it $16 instead. How many wreaths would she sell? She would sell 60. Okay, you don't have to write this down. She would sell 60. So 60 times 16 would give you $960. You're starting to make more money. Okay? If she increased her price by another $2, how many would she sell? 75. And that would be how much? It's supposed to be, oh, decrease, we're decreasing. Oh, Johnson, thank you. Let's try this again. What is she doing with her money? She's decreasing the price. So this was 16, so that was right, which was $960. So this should have been 14. So decrease it by $2 again. 1,050. Okay? If she keeps going with this trend, let's say she decreased it, I don't know. Is she going to always keep making money, or is it going to start to fall? Like sooner or later, you're charging less and less and less. It's going to follow this quadratic pattern. It's increasing. There's a maximum amount she should actually charge, or what is that maximum she should charge, or the value she should charge to get that maximum revenue. And that's what we're going to look at. Okay? So revenue, would you agree that revenue, in this case, is equal to the number of wreaths she sells times the cost per wreath? Would you agree with that? The revenue in this case is the number of wreaths times the cost per wreath. That's what we're doing, right? 60 times $16. 60 was the number of wreaths. $16 was the cost per wreath. That gave me my revenue. Okay, so what am I doing to my number of wreaths every time? What was I doing each time here? Increasing by 15. So for every $2 decrease, I added 15 wreaths. Okay, so our variable is going to be a little bit different here. We're going to let x be the number of $2 decreases. The number of $2 decreases. Okay, so in the very first one here, how many times did I decrease by $2? Once, right? Because it just went down $2. How many times did I decrease by $2 to go from 18 to 14? Twice, okay? So our number of wreaths is going to become, so revenue equals the number of wreaths for every $2 decrease. What did we do to our number of wreaths? You add 15. So we had initially 45, and we're going to add 15 for each x, for each time we decrease the price $2. Okay? And the cost was initially $18, and we're going to, for each time we decrease the price for $2, so it's going to go down by 2x. How many times we decrease by $2? Okay, let's see if that makes sense. If x was 1, I would get 60 times 16. Do you see that? If x was 2, I would get 45 plus 15 times 2, or 45 plus 30, which was 75. And if x was 2, 18 minus 2 times 2 becomes 14. Right? So that's how we're setting up our formula. X in a revenue problem will always be the number of X dollars increases or decreases, depending on the question. Okay? So, I did not give us enough room. We need to expand this. And how are we going to expand it? Ooh. Let's go back. How are we going to expand? Our good friend, FOIL. Okay, 45 times 18, 810. 45 times negative 2x, negative 90x. 15x times 18, it's a little harder, 270x. And then last, 15 times negative 2, 15x times negative 2x, negative 30 x squared. Okay. So I'm going to rewrite this. X squared first, negative 30x squared, collecting our like terms. So if you have 270x minus 90, gives you 180. And then our constant is 810. All right, so what we want to do here is we want to complete the square. Sorry if you're running out of room. So we'll try and do this as the least amount of steps as possible. If I'm completing the square, what's my first step? Get rid of the negative 30 by factoring out of who? All of them? No. The first two. Yeah, the first two. So we want to factor out the negative 30 from the first two, which gives you x squared. When you take negative 30 out of positive 180, what happens to the sign? Negative. Negative 6. X. Okay, let's leave some room so we can complete the square right now. And then the 8/10's outside. Negative 6 divided by 2 squared. What does that equal? 9. So add 9. Subtract 9. We need to bring which one outside? The negative. So this becomes negative 9 times negative 30. Negative 9 times negative 30. Hey. Which one? Not here. Not here. Yeah. Negative 9 times negative 30. Positive 270. Two negatives, right? So our completed square form becomes revenue equals negative 30. What does this become as factored form? X minus 3 squared plus, collecting like terms, 1080. Okay, so our vertex was, what's our vertex? 3 and 1080. Meaning, what did the 3 stand for? X. And what did X stand for? Which is the number of $2 increases. What did the Y stand for? The revenue, max revenue. Because our variables in the equation were X and R. X and R, okay? So, if I ask you, there's two things I can ask you, which I think I did. This is very important. I'm going to erase this part up here. Okay? There's two things I can ask you. The first thing that I can ask you is the cost of the wreaths. The second thing I can ask you, actually there's 3 things. 4 things. I could ask you for the number of $2 increases. I could ask you for the maximum revenue. I could ask you the price of the wreath that you should sell it at, and how many wreaths you'll collect. Okay? And that's where you want to go back to your original equation up here. The revenue equals the number of wreaths times the cost per wreath. What was the number of wreaths? We said the number of wreaths was equal to what in terms of X? 45 plus 15X. And so X is actually equal to 3. So the number of wreaths we're going to sell would be how many? 45 plus 45, or 90 wreaths. Okay, so I can ask you how many wreaths. I can ask you the cost per wreath. What formula did we come up with for the cost per wreath? 18 minus 2x. And so in this case, it would be 18 minus 2 times 3, which is $12. Okay? So on a side note, if we continued that pattern, we kind of would have seen, like, initially we had 45 times, they were how much? 18, right? And then by every time we decreased it by 2, we sold 15 more. And so we could have, you can kind of double check your work by following that pattern. Oops. 12, right? And seeing what happens. So then after 90 would be 105 and 10. And so, right? For every $2 we go down, we increase the number of wreaths by 15. So I could have found all these products and seen what happened as well. And check my work that way. That works too. Which is, unless you're going to increase it by a decimal, like 3.5 increases. So it doesn't have, right? It doesn't have to be a whole number of increases. But if you did that, did someone have a, oh, I have a calculator. It's on my computer. Convenient. Okay, so if we did that, we did 45 times 18, which was a revenue of 810, 60 times 16. I'll just type them in here, 75 times 14. See what happens? 90 times 12, 105 times 10. It starts to go down again. Do you see that? It's a quadratic relationship. Then if I go 120 times 8, so see our revenue starts to decrease. Okay, so you can do that to check your work. All right. Should we save this one for tomorrow or do it today? How are we doing? Tomorrow? Okay, let's do one area problem. Yes. Okay, go back up. I'm over. Yeah. And up. So this question was asking what was it asking? How many wreaths will she sell and how much money will she earn if she sells at this price? So what should we actually answer? We need to answer that question. So how much should she sell it for? So $12 per wreath will bring in how much? Will bring in $10.80 revenue. That's how much she'll bring in. That's answering the question. Kind of important to do. Because otherwise, why are we doing this? I don't know. So all revenue problems are going to be set up the exact same way. The X is going to be always like in the next question. Let's just quickly look at the next question and we can finish it tomorrow. A theater company currently charges $12 a ticket. At this price, they will sell, the 450 will attend each show. For every $2 increase, 25 fewer people will attend. So what's your X going to be? The number of $2 increases. The number of $2 increases. Revenue in this situation would be what times what? Okay, so the number of tickets times the cost per ticket. So it's always going to be the same. The number of something times the cost per something. Okay, so you'd set it up the same every time. Yeah. So 450 is in originally, and you're going to have 25 fewer, so minus 25x. Yeah, the people go together. So 450, and then you have 25 fewer. And then this one, the price, the cost, initially was 12. And what are we increasing it by? 2. So then it's 2x. 2 plus 12x. Sorry, 12 plus 2x. I said that backwards. Okay, every situation is going to be the same when we set them up. And then from there, FOIL it, complete the square, answer our question. Okay, so let's finish this one tomorrow. But setting it up, pretty easy, right? Should be. They're always the same, always. Number of something times the cost for something. Same way. And X will always be your number of, dollar number increases or decreases, depending on the situation. Okay? Let's do an area example 4, and we'll leave example 5 for tomorrow. Okay? So finish Wednesday. Unless we want to finish it today and then we just have more of a work block tomorrow. We could talk about that later. Okay. It's kind of boring. We've done so many of these. That's okay, they're important. I should have made it more interesting than just a regular rectangle. Look at a triangle. That would be more interesting. I'll do a problem like that maybe than do now. A rectangular playground is bounded on one side by a wall So there's a wall. And on the other three sides, by 60 meters of fence. And they tell us it's a rectangle. Very exciting stuff. Determine the dimensions of the largest possible playground. So the question is, what are we trying to maximize? So largest is maximize. What are we trying to maximize? Area. We want to maximize area. And so area is the formula we want to work with. Area is equal to what of a rectangle? Length times width. Okay, problem. What's the problem? There's three variables. What do we know about this fence? There's 60 meters. And 60 meters is made up of what? One length and two widths. So let's isolate which variable? L. So length is equal to 60 minus 2w. We'll subtract 2w to the other side. So now we can replace it in our area. Area is length times width, and our length is 60 minus 2w times w. I'm going to get rid of that dot because it looks like a subtraction. All right. Good? Okay, let's expand. I'm going to rewrite this in a different order than what it naturally goes to because I want w squared first. So what would be first? Negative 2w squared plus 60w. Ooh, that was funny. Okay, if I want to maximize, whenever you're looking for the maximum or minimum, we're looking for the vertex. Okay? That's something that's going to be easily forgotten about when you get to the end of this unit. And we mix in a different type of word problem. You have to remember which is which. So whenever we're looking for maximum, I need the vertex. I need to complete the square. Okay? Every time. All the time. What's the first step? Isolate w squared. So we want to take out negative 2. Are we taking it out of both or just one of them? Both. Anything with a variable. There's no constant here. So it happens to be both of them because they both have a variable. So dividing both by negative 2. We get w squared and then minus 30w. You might want to leave room. We can complete the square right now if you want. Okay. Negative 30 divided by 2 squared. 15 squared is 225. Move that bracket. Okay, to take the negative out, what do I have to do? The negative 225. That's not green. Multiply by negative 2. So it becomes negative 2 times negative. Make it a little larger for you guys. Negative 2 times negative 225. Plus 450. Good. Okay, factored form becomes w minus what? 15 plus 450. So what did the 15 represent? The width, what does the 450 represent? Specifically, what part of the area? Yeah? There's multiple areas that are possible. Which area is this one? The max area. So when the width is 15, the max area is 450. So once we're done that, we need to figure out, okay, what were they actually asking us to find? Largest possible paragram. So what is that? Dimensions. So if the width is 15, how do I get the length? Not 15 minus 60. No. We had a formula for length. What was it? 60 minus 2w. Remember there's two widths? Two of them are 15. So length would be 30. Is this meters or feet? Meters. So dimensions are 15 meters by 30 meters. Would maximize area. Good? Yeah, it might be a little bit more complicated in your homework. Not always. Actually, sometimes they're that simple. If it's a word problem, although if it was a word problem on your test, it probably wouldn't. No, if I say algebraically solve, then it's mean, yeah. In this one, no, you don't. You're right. You can reason your way through it. This one's pretty simple. Okay, so we're going to leave it here. Okay, you really want to start practicing these word problems because they're going to show up on your quiz, and they will show up on your unit exam and your midterm. Hooray! Okay, so the assignments on the board, page 192 to 197, 13 to 15, 18, 19, 21 to 24. Start with those ones and then do the 8 BC, 10A, 12 CD, even though they're the same page. Okay, you need to practice, guys, because it's not going to get easier unless you practice, I promise.